So let me get started. This is my Capstone serverless general event management system, and I'm Kim, and Dr. Samchung is my advisor. So let's go. This is the agenda for this is the agenda for today. To save some time, I'm not gonna go over really all the little details, which I'm going to explain to you guys later anyways. So first off, problem statement is how can we develop low maintenance, low cost, highly secure, highly manageable, and reusable solutions for event management system? I am not the first person who have this question, and on the bottom of the screen, it is some of the references of people who have looked into the similar problem. And the motivation came from a project I do at work, which is at KICA organization, a nonprofit organization, where we re-engineer a legacy system to a serverless system. And the motivation basically is for my capstone is to encourage organizations to adopt cloud computing, reduce technicality debts and serverless computing, and to increase the ease of serverless testing and testability. Again, the references are on the screens of people who have also looked into the same problem in the past. And background, a little bit of explanation of some of the most common terms that is going to appear again and again in my capstone. Re-engineering is basically where you have to redesign a business processes, system, or structure. Cloud-based refers to any operating system, hardware, software that is internet-based. And then serverless is basically where developers can just focus on developing the software and don't have to worry about anything about hardware, which is taken care of by the cloud provider. That includes hardware resources, allocation, servers, etc., etc. And then finally, general event management system. It's the system as a final product of my capstone, where people can use this software to create and manage events. General is because I want to make it as generalized as possible so it can be reused for different organizations, right? So here are some of the related works that I have looked into, and I have used 3 criteria to compare them. First one, serverless, and then project management, and then software for full stacks. And for all these 3 related work, mainly for serverless computing, they have mentioned AWS here and there, some of the services. However, not too much. For the project management side, not really a lot was mentioned. They do recognize that there's a difficulty in technical project management. However, not really any solution was suggested. And then for software, for full stack development, again, it was only mentioned, but not so much, or almost nothing. So with that, here's my approach. Since I am already working and I have a legacy system to work with, this is the approach or phases that I use to accomplish my capstone. First off is to learn and understand the existing legacy system, and then redesign the system with OOP, MVC, and cloud technology, and then implementation, and then testing, and then deployment. And then with that, I combine approaches back to compare again one more time with the related work. And as you guys can see in the last column, KN approach is my approach. And I had a lot of pieces in there where serverless computing, where I mainly look into AWS. I also look into serverless.com, which is another option for serverless development. And then for project management, architecture management, and knowledge management, mainly I use Atlassian softwares, which are including Jira, Confluence, and then SparX for UML and documenting. And for full stack development, I do have the implementation as well, and those are the technologies that you guys can use, can see. So with that, phase 1, understanding and learning the legacy system. So this is some of the snapshots from the source code of the legacy system. It is mainly used PHP and Microsoft SQL. And They are monolithic and is locally hosted, which means it is all spaghetti code. There's no structure, very messy and very easy to be attacked. So here is another view of the legacy system as well, where you see there's client side accessing application server, and then application server can access the database and the other way around. So with that, after understanding the legacy system, here's the design of the targeted system, where I want to have multi-tier architecture. I want to go serverless, and I want to make it possible for future mobile development as well, if anything needed to be added in. And that is the picture you're seeing is the high level of how the target system works. And here's a more detailed one where client access Route 53, and that's the endpoint where they can access the software. And then for the front end side, which is in the bottom here, where the data will be rendered through CloudFront, and then the source code of the front end will be hosted in S3 bucket, where the bucket is kept private. And I use AWS Cognito for authentication, and then Lambda function is the backend, and it will be accessed through API gateway. And AWS IMA is used for admins, where they can go and have full access to the database. And again, here database and AWS Lambda function can access each other. Okay. So implementation here, the pictures you guys are seeing is the front-end source code where I use React. Yeah, so this is a basic React structure. I'll show you guys the demo a little bit later. And then for the back-end picture on the left-hand side here is the source code and the structure. And then again, I use API Gateway, Lambda function, Cognito for authentication, and I use both Python and Node.js. And also I use AWS Amplify as well. Phase 3 implementation continue with database. So database is, I actually started with RDS. However, for the final project of the demo, I have used DynamoDB just because it's a little easier. And then for testing, actually, I do testing alongside with implementation. Every time I implement something, I test right away. Testing mainly done in the AWS environment, VS Code, and Amplify. And deployment for the front end is deployed in AWS S3 bucket, and then backend is deployed into Lambda function. And I use AWS Amplify to do both of the deployments. Data collection, so I collect the data by looking at the legacy system and the new system that I have implemented. That's for the software side to see is there any improvement and how the performance is going. And for the project management side, I collect the data from Jira software, which is a project management software where you can have cards and tabs of tasks that your team can collaborate with each other and to complete. You can also link the GitHub repository in your project as well. And then I also look into Confluence software, which is another one from Atlassian, where it helps you with documenting your products. And as you can see here, there are quite a few documents, and the structures are pretty nice to look at. So data analysis, here are the criteria of me judging my Capstone and analyze my Capstone. First is security, and then speed and reliability of the software, scalability, reusability, and cost. With that, for the new system or architecture that I have implemented, the benefits are the security of the cloud is absolutely good because it's taken care of by AWS. Speed, absolutely much faster. Reliability, for sure. Half of it is also guaranteed by AWS since you are using their software and services. Scalability with the new architecture is much easier to scale, to change services, and also to integrate. Like say later on, if I want to add mobile development, it's very easy, and also cost effective since it's pay as you go. However, there are still some cons, which is learning curves. It is not it took quite some time to learn the knowledge of AWS and also cloud computing. Lambda development, especially, looking at it, it seems easy, but however, in the hands-on time, a lot of difficulties come out. And then security in the cloud is what we have to take care of as developers. And then the integration between different services is not that easy as well. So for fighting, however, with the pros and cons, I would still say that AWS and Atlassian are really good solutions for low maintenance, low cost, highly secure, and highly manageable softwares, or softwares that you can use to develop for your development. Future work, I want to finish the application as well. I didn't get a chance to finish all the application, and I want to integrate with AWS SAM, which is a software to manage serverless computing. And I want to develop infrastructure as code using SAM, and also I want to integrate code commit, so it's easier for the whole team to share the code together. And let me show you the demo. Let me know if you guys can hear the video, the audio. This is the demo of my application, and this is the home page. Can you guys hear?
Yes, yes.
Okay. And then we have the events page where all available events are listed. And by clicking on any of the cards, it will extend and show more specific detail about each event. And here are some examples. And then we also have login page. So when I click on that, I will be required to log in. There's also an option to create a new account if you have not. Once you sign in, you'll see a change in the interface where users will be able to create, edit, or delete their events. And this is the UI for the users, not the admin. So if they click on create events, they will be redirected to this page where they can fill out some information for their events, like event names, event date, and also event description. And below the section to create the events, you can also see that you can select existing event that you own or created before to edit or delete. So you can just choose the name of the event and then hit edit or delete. So now let's go back to submitting to create a new event. And once submitted, the admin will be able to see the information in the DynamoDB. And then let's look at the Amplify application. Here's the front-end environment with the domain URL. And then in the backend environment, I have authentication functions and API. And clicking on any of those will extend with more information. Same goes for API and functions. And then let's look at AWS Cognito. This is the authentication settings and service. Right now I have one user, which is myself. So if I click on that, it is shown that my email is verified. And then we have cloud formation, which is have all the stacks of all the applications that I used. So this is one of the example for Cognito stack, and this is all the services behind Cognito and the authentication. This is another stack for Lambda API and also S3 bucket for hosting the front-end application. And this is my source code. This folder, SRG folder, has the front-end. App.js is the entry point. And then under components, I have all the CSS, all the events, all the pages, and then I have the component items. And then I have the public folder with images and videos used for the website. And then the build folder is a compressed version of the application to upload on the cloud. And then in the backend folder, this is where API authentication and function are located. And we can extend more to see the details. And that's pretty much it for my demo. Thank you very much. Yep. So that's it for my capstone. Thank you for your time. And is there any question?
I have a question, Kim.
Yes.
Thank you very much for the presentation. Great job putting everything together, start to end. My
Thank you.
question, my question is regarding Jira. Can you go
Yes.
back to the slide where you were showing the swim lanes in Jira?
Here you are. Yeah.
So I saw there were more than uh yeah. So there's a couple of people involved in this Jira project. How did you guys interact with each other?
Mm. Yeah. In the beginning, yeah, it was several people. So the way we there are several methods, not only through Jira.
Mhm,
So and actually Atlassian and Jira as well, they have the feature where you can do daily Scrum.
mhm,
So it fits perfectly for Agile. So you can go in there and you update your daily Scrum, and then as a project leader, the person can go in and have a look, or for other people as well.
mhm.
And also for this picture on the left here, this is where we have the task that needed to be done. If it's assigned to a specific person, then that person just come in and get it done. If it's not, then the whole team kind of pick on it and choose the
Wow.
task for themselves. Or sometimes we even have the column where we have roadblocks and we just throw it in there, and then the whole team come in and see if there's anything anybody can answer and help. Um, and this code tab is, and this repo is where the GitHub is linked. So let's say if you solve a problem in any of these tags, then you just link that, just push the changes in GitHub, and it will reflect in these tasks as well. That one problem has been solved. So something like that. Yeah.
Nice, nice. So what features would you assign to each of these tickets? Maybe priority level, time sensitivity,
Yeah.
assign them to someone.
Yes, you can do that. You can have like detailed description, task due date, and feature, and then you can link it to the GitHub repo. Yeah, pretty much all there is.
Wow, great. Thank you very much.
Thank you.
Thank you, Kim. So if anyone has questions, so please ask her on chat box, and let's move on to